Good afternoon. I'm Anuj Mehrotra, Dean of the George Washington University School of Business, and it is my pleasure to welcome you to our first episode in our spring season of the George Talks Business Series. And I am delighted to announce that we have partnered with the Schools of Engineering, Law, and Public Health to host a series of sessions on artificial intelligence in this month of February and invited some of the leading experts in the AI field to join us as guests. Our goal today in this opening session is to set the stage for the AI series by gaining an understanding of what's happening in the field of artificial intelligence globally and hear about some of the most pressing issues and examples that keep AI experts awake at night. Our distinguished guest today is one of the pioneering thinkers in the field of artificial intelligence. Dr. Stuart Russell, a professor of computer science with Smith and Smith ZA Professor in Engineering at the University of California, Berkeley, honorary fellow at the Wadham College, Oxford, and author of Artificial Intelligence, A Modern Approach, and Human Compatible Artificial Intelligence and the Problem of Control. Thank you very much for joining us, Professor Russell.
It's a pleasure to be here.
So, Professor Russell, before we talk about artificial intelligence, its risks and benefits, can we talk a little bit about your background? As an undergraduate student, you studied physics at Oxford University. What brought you to Stanford to study computer science? And how did you become interested in artificial intelligence?
It's a great question. Well, I could say the weather is what brought me to Stanford. So actually, although I always planned as a young boy that I would be a physicist, I became interested in computers as a hobby. I think I got my first programmable calculator when I was about 12 years old, Sinclair Cambridge programmable, and you could write programs that were as long as 36 keystrokes. So I quickly figured out that it was hard to do AI using 36 keystrokes on a calculator. But I had read a couple of books and I became very interested in the whole area of AI. But I always assumed that that would be a hobby and that physics would be my life. And then I spent a year before I went to Oxford working for IBM. So I learned a lot then about computer science as a discipline. And I became aware that you could actually be a computer scientist, that it was a real academic discipline. You have to remember this was at a time when there were almost no degree programs in computer science anywhere in the world. And once I figured out that you could do a PhD in computer science and artificial intelligence, and the people that I knew recommended that if I could go to Stanford or MIT, then I should do that. I applied to both of them. MIT returned my application unopened because I had missed the deadline. And Stanford was kind enough to be patient and wait for me to take the GRE, and then they admitted me. So it was fate.
So now, of course, you have been in this field for a while. You're a pioneering thinker in artificial intelligence. So I want to ask you, how would you describe the present state of artificial intelligence overall? Particularly, how is it different across the globe? And of course, people like me feel that artificial intelligence has grown exponentially fast. Is this really true? Am I correctly feeling it? Or is it been just a natural order of business that it had to grow this fast from the time that you had started thinking about it?
So I would say that the present view that most people get is that AI didn't exist prior to around 2012, and it's grown exponentially fast since then, and that AI and deep learning are more or less synonymous. And you will see this viewpoint stated even in very serious documents produced by national academies and other organizations that really should know better. Because AI has been around since the 1950s, and we've gone through several periods of exponential growth and then exponential deflation. The first one in the 1960s, where, for example, people were very excited about machine learning based on neural networks. In the 80s, when people were very excited about commercial applications of AI in the form of so-called expert systems, which were systems composed of large numbers of rules that humans would supply. And the idea was that those systems could do the knowledge work that actually constitutes the majority of what happens in advanced economies. And then the current boom dates to the introduction of deep learning technology, which is neural networks on steroids, you might say, where the networks have a large number of layers, and we train them with very large amounts of data. And they have achieved impressive performance in important areas. So I don't want to say that really this is just history repeating itself. We really have made very substantial advances in real capabilities, speech recognition, machine translation, computer vision, to the point now where things that we used to think of as dreams of AI. So John McCarthy, one of the founders of AI, said that his dream would be that one day he could get into a car and the car would drive him to San Francisco airport. And now that dream has really come true. You really could get into one of the self-driving car prototypes, and it really would take you to San Francisco airport, and it would be safe. Wouldn't be
And
so
it may
safe.
actually be better than me driving on the car myself. So you're talking about these dreams that people had about AI. Let me take you back and ask you a question. What was really the goal of artificial intelligence? And is artificial intelligence actually helping us meet these goals? And perhaps, like you were taking some examples, if you could give us some cutting edge examples of what AI is able to do today and what is it achieving, that'll be great.
Yeah. So the goal of artificial intelligence at the beginning, I would say, was actually not very well defined. When you read Turing's paper, for example, so his paper, Computing Machinery and Intelligence from 1950, he just takes it for granted that making machines intelligent is a good thing to do. And in proposing what we now call the Turing test, he appears to be equating intelligence with the ability to imitate human beings, or to do whatever it is that human intelligence does successfully. And so for the early years, I would say there wasn't a clear distinction between AI as an engineering discipline, where we are trying to create artifacts with certain useful properties, and AI as a science discipline, where we're trying to propose and test theories about human intelligence. And now these are really two quite separate disciplines. So cognitive psychology and cognitive science is about the empirical questions of human intelligence and how it works and how it doesn't work. And AI has largely become the engineering discipline about creating artifacts that exhibit certain useful characteristics. And if you had to say, well, what particularly is the engineering discipline, right? It's not mechanical engineering, it's not civil engineering. What is it? It's about what we call creating intelligent agents. So an agent is something that perceives and acts in some environment. And you might say, well, isn't that a thermostat, right? The thermostat perceives the temperature and then switches on the heater. So does that make it an agent? And the answer is yes, it's an agent. So there's no hard and fast dividing line that says, okay, these agents are intelligent and they're studied in AI, and these ones are stupid, so they're not studied in AI. It's a spectrum. The spectrum being how much computation is available to the agent to make its decisions, and how complicated is the task environment in which we put it. So if I want to build an agent that's going to teach children string theory, then that's a really complex task environment, because the physical environment that you're going to put the agent in contains human beings who are incredibly complicated, and its task is only achieved if it succeeds in teaching them string theory, and it's going to need all of its computational resources and more to do that. So there's a spectrum, and AI is kind of interested in the high end of that spectrum, where there's a decent amount of computational resources and the task environments are complex and really make use of all those resources to come up with good decisions.
So
And when
tell me a
when
little
you
bit
think
about
about
those examples.
yeah. So um, when you look at the current landscape of where AI is being used, I think we can distinguish between the what we might call the real physical environments. So that would be, for example, the self-driving car, or the assembly robot, or the fruit picking robot, or whatever it might be, and then the software environments where the intelligent agent exists only in the cyber realm. And in many cases in the cyber realm, we're not so much interested um, in decisions that have long-term consequences, in the sense of thinking about what the result of my decision is going to be, and then I'm going to make another decision. So we're not worrying about the sequence of actions that happens in the future, but more classification problems. So I get an input and I produce an output, and then I move on to the next problem. So machine translation, you get a piece of text, you return the translation of it, and you move on to the next problem. A recommender system, you see the current state of the user, and you recommend that they buy a certain book or that they watch a certain video, and then you move on to the next problem. So these are more like classification problems, just mapping from a set of inputs describing a state to this is the right thing to do, and then you start a new problem after that. And so recommender systems, I would say, have been financially probably the most significant part of the AI ecosystem. And when you go to a machine learning conference, you will see many, many, many papers about how to improve recommendations for all kinds of content. I personally find machine translation to be incredibly valuable, partly because we have an apartment in Paris, so I have to pay French taxes, and so I use online translation to help me translate the French tax documents into English ones that I can't understand either. And but the range of applications now is just enormous. So if you're in HR, for example, you're almost certainly using AI systems to filter all of the resumes that you receive every time you advertise a job position. If you're in manufacturing, you're probably using AI. In fact, you may have been using AI for decades to do your supply chain management and to do online monitoring of equipment for failure and things like that. So I think fairly rapidly we'll see AI systems being used to some extent in pretty much every area of the economy that human decision making is involved, because even if you can't make decisions at the same quality, you can make decisions at a much greater scale, and uh, and so in many cases you can reorganize your workflows to incorporate AI at some point in that process, and get a more efficient, more effective system. And this mantra that you hear often, that AI is going to augment human work and allow human beings to focus on the part that they're better at. Um, Although that sounds a little bit like marketing spiel, I think there's some truth to it, because I think an awful lot of what people do is repetitive, and they wish they didn't have to do that part of their job, and they just kind of get used to it, and it's part of life.
Right. Right. So,
But that
Stuart, so
that will change.
one of the things that comes to mind is a lot of audience, of course, ask this question, and it is something which is a general expectation, a sense of expectation of how AI is going to change in the near future. Would love your thoughts on what you see is coming down in the near future, as you started to talk about, and also perhaps what some of the current trends in artificial intelligence are, which will change the world around us. There is a sense of expectation. So I would love your comments on that.
Yeah, so this is a time of a real uncertainty, I would say, in how the future is going to unfold. we've gone through, as I said, a period over the last 7 or 8 years of rapid improvement in the capabilities of machine learning technology, particularly for these high dimensional real world perceptual inputs like speech and imagery. And that will continue to produce benefits. We'll be able to roll it out as robust, well-engineered, dependable technology in more and more areas. But I think there's a sense that perhaps the deep learning wave is going to break, and the capabilities may plateau, and we won't be able to push ahead to some of the more difficult problems purely using end-to-end deep learning. And one example of that is in self-driving cars, where several of the major groups asserted at the beginning that they were convinced that end-to-end deep learning was the solution. And whether you do that by instrumenting a bunch of cars that human beings are driving and therefore getting training examples from that kind of data, or by running in simulation and using reinforcement learning so that the car learns to drive itself. But those techniques have pretty much failed, I would say. And the reason it's failed is because there's just never going to be enough training data in the universe to take that approach. If the system doesn't understand what it's trying to do and doesn't understand how the world works, then it cannot cope with the variety that the world throws at it. Because if you come up with a situation that hasn't appeared in your training data, you have to solve it from first principles. You have to say, well, here are the things I could do, and here is what would happen if I did those things. And, oh, now I see that I should not do this because that outcome would be very undesirable. And this other outcome, so if you've never seen a flock of sheep before in your training data, and now you're driving along a country lane in England and there's a flock of sheep in the road, and what do? Well, if you understand the way the world works and what it is you want to have happen, you can figure out what you ought to do. And so this is happening over and over again in all of the trials of these self-driving cars, that they keep producing situations where there's nothing in the training data that can tell them the answer. But if they could think about it from first principles, if they could project forward into the future, if they had a way of deciding which future is better than which other future, then they could proceed. And if you think about it, that's how we write chess programs, right? Chess programs work not by consulting a vast database of previous games and saying, oh, I know what to do in this situation. They work by projecting forward into the future and applying a criterion of desirability to the different futures to figure out which one you want. And Waymo is one of the car companies, self-driving car companies, that's been using this approach now for several years, and it's turned out to just work better. So I think this is one direction that things will go, away from end-to-end deep learning and towards systems based on models, on prediction, on evaluation, which is really the classical approach to building AI systems. Another approach, I think, is that knowledge is going to regain its prominence. So for most of the history of AI, the idea was you built systems that know things, and then the system, if it knows things, it can reason and come to conclusions. And reasoning doesn't exist in deep learning, right? You either know it or you don't, and there's no process of reasoning that deep learning systems can go through. They're not constructed to do that. And increasingly, we're seeing why it is that knowledge and the ability to reason confer benefits on the AI system, because it exponentially expands the set of problems that the system can deal with. It also allows it to learn much better from experience. So when humans learn, we bring to bear a massive amount of knowledge to allow us to interpret the new example and generalize from it. So when I teach a child to recognize a giraffe, right, if you buy a picture book, they have one picture of each animal. Right? I mean, whereas the picture book for a machine learning system would have a million pictures of each animal, right? And then it would be the size of a whole library of a million pictures of a giraffe. And humans don't need that because we come to each learning task with a massive quantity of prior knowledge that allows us to learn quickly from each new experience. And so I think really the pendulum is swinging back towards concepts that we have believed in AI for a long time. It's just that I would say, did not succeed in the early years in putting those concepts into practice in ways that were robust, that could connect up to real world data, video and speech and so on and so forth.
Right.
And so now, hopefully, the integration of these two will be an enormous
right.
win for the field.
So let me change it. In some ways, what you're telling is comforting because with facial recognition systems combined with the social media presence that we talk about, should I was assuming, everything that is about us is known or is knowable. But you're saying that there is still that stage about being able to reason, which is not the case. So let me take you 20 years from now. In 10 years, we have seen exponential growth of artificial intelligence. So in 20 years, what do you think it will do, and what kind of breakthroughs that you mentioned are needed in order to really reach human level artificial intelligence? The super intelligent AI is what some folks are calling it, right? So what are those breakthroughs that are necessary, and when do you think they should be expected?
Okay, so that's a lot of questions in one go. So I'm going to sort of take it in chronological stages. So what do I think is going to happen in the next decade or so? So I think as we start to combine these pure machine learning systems with systems that are able to acquire, accumulate, and apply knowledge and reasoning and deliberation, we'll be able to have, I think, really effective systems that can help individual people with their lives. And this sort of comes in an opportune moment, right? A moment where the blogosphere and various other spheres are realizing that the bargain that we've made between people and the tech corporations and the information ecosystem, that bargain is kind of a bad one for a lot of people. And so I think we would like to see systems that are designed to help the individual rather than designed to extract money from the individual. And so those systems can be built if they understand the individual's preferences, their daily activities, the sort of fabric of their lives. To be really helpful to me, it has to understand, what I do, who my family is, what my family do, where I live, et cetera, et cetera. And we can start to build these individual assistants, whether it's for daily life or for finance or for health or for education, that can really deliver value to individuals rather than the corporations that feed off the individuals. So that's a huge thing that I think will happen over the next decade, and it'd be facilitated by progress in language. So if you said the last decade was where we really made progress on vision, I think the current decade will be the one where we really make progress on language. And it's language that allows the system to actually exist in our environment and understand what's going on in our environment. And that will be crucial both for these kind of assistant types of systems, but also for lots of commercial applications. If a system can read emails and read the announcements that come down from management and understand them, and so on, then they can function in commercial environments as effective assistants to human beings working there. So going ahead from there, one of the things that language does is give the systems access to all of human knowledge. So most of what we know, at least in the sort of scientific and cultural and technical sense, is written down. And it's written down in natural language with a bit of math thrown in. So systems that can understand language can then process that information. And that's one interesting thing that machines have that humans don't, is this sort of scale effect. So it might not be as good as we are at reading and understanding text, but it can do it on a scale that we cannot approach. So you can do the maths, and it would take one of the current supercomputing systems on the order of a day or two to read everything the human race has ever written. And to understand it to some extent, and to do that in every human language, and possibly even languages that we don't even know how to translate. So artifacts and documents from ancient cultures that have remained inscrutable might become interpretable to such a system. So that would be a huge step towards the question that you asked, which is human level AI. I think there are other really important steps that we don't yet know how to take. And to me, the most important characteristic of human intelligence is actually the temporal scale that we can achieve. So let me try to explain that by example. So if you look at Alphago, which is the program that DeepMind produced that learned to beat the best human Go players in the world. So one of the reasons it's able to do that is because it can look ahead very effectively in the game. So it can look ahead 50, 60, 70 moves into the future, which is more than people can do. But if I take that same algorithmic approach and apply it to a physical robot in the real world, right? Well, what is a move for a physical robot? Well, it's sending a command to the motors, right? So you adjust, basically robots adjust the voltage or current to their electric motors, and that moves their arms and legs around. And that might happen 1,000 times a second. So looking ahead 50 or 60 moves into the future gets you, less than 1/10 of a second into the future, which is of no use whatsoever, right? If I want to drive you to the airport, or if I want to lay the table for dinner, I need to be thinking, that's an hour of work. And so that's millions or even billions of motor control steps. And so there's no chance you could take the kinds of algorithms that AlphaGo uses and scale them up to allow a real robot to function in the real world. Because, as I often say, your human life consists of 20 trillion motor control steps. So it's like those old chess programs, play and win in 3 moves, except it's play and win in 20 trillion moves. And so we need completely different methods to handle that kind of temporal scale. And the way humans do it is through multiple layers of abstraction. So hierarchical decision making on all of these scales, seamlessly, continuously, and flexibly as well. We construct and deconstruct and reconstruct these hierarchies all the time. And some of them come from our culture. So, a decision to do a PhD is not a kind of action that we invented, right? Our culture invented it over 800 years. And then it becomes a thing. But once it becomes a thing, then you can do it, right? You can choose to do it. And so you can make these multi-year plans because your culture and your upbringing equip you with these hierarchies of vocabulary about useful actions and useful properties of states. So we're just at the beginning of trying to understand all that. And if we do succeed in that, I think that will be a massive step towards human level intelligence. The other big step is I think the sort of analogous approach on the learning side. So how do we achieve cumulative learning where everything we learn is sort of fed back into a cumulative loop that allows us to learn the next thing a little bit better and the next thing a little bit better. And that's another key characteristic of human intelligence. So with those 3 things, access to all of human knowledge through language, the ability to make decisions over long time scales with hierarchical abstractions, and the ability to do cumulative learning as knowledge builds up and allows you to learn better. with those three things, I think we have something very close to human level intelligence. It's very hard to say when that's going to occur. And people always ask me, what's the time scale? And I always say, I'm not going to say, because so many people have made those predictions in the past and they've turned out to be wrong. And usually they're wrong on the side of being overly optimistic, that they say it's going to happen. I mean, I think Herb Simon in 1963 said it would be 10 years and we'd have systems that could do everything the human being could do. And that turned out to be not quite true. But on the other hand, just a few years ago, people were saying it would take 100 years before we could beat the human Go champion. And it took less than 10 years. So sometimes we get these upside surprises. And we have to be careful about.
So I'll get you off the hook about the prediction of time, but I do also want to hear. I mean, these are all very positive things, and you're talking about optimistic projections, etc. But there's also a lot of conversation about how things could be misused and how artificial intelligence development could be misused. So could you maybe identify some examples of some of the misuses of AI? What would keep you awake at night in terms of the kind of development that might take place?
So I think there are misuses that are happening already. And those include AI systems that produce disparate negative effects on certain groups through bias in the data sets or through poor design of the objectives that we use to train the algorithms. And this could be in employment. So systems that filter resumes. It turned out, for example, that Amazon was filtering out all resumes that mentioned the word woman. So if you were a member of a women's group, or if you were part of a group that advocates for women in technology or something like that, that would be an automatic red flag for the algorithm, and it would kick out your resume from the pile. And that was simply because the algorithm noticed correctly that most of the people that Amazon had hired in these technical positions were men who didn't have the word women in their resume, and so it assumed that having the word woman in your resume was a reason not to be hired. So it was reflecting the bias that already existed in the human hiring process, and so that was a combination of, okay, the data are biased, but also the objective was wrong. The objective is not to come up with a predictor that reflects past history, right? That agrees with the training data. That's not the objective. The objective is to get something that actually hires good people and does so in a fair way. And now we're starting to understand, how do we get the fair part into the definition of the objective? And so that's, I think, progress. So that's an area where the misuse of AI has been recognized, and the discipline, companies, governments are starting to figure out how to fix it. The use of AI to kill people, I would suggest, is a misuse. So writing algorithms that can decide to kill human beings is probably a bad idea. And this is the area which some people call lethal autonomous weapon systems, or killer robots for short. And there's a number of reasons, right? You might just say, well, obviously that's a bad idea. We shouldn't have machines killing people. But to convince a government that it's a bad idea, you've got to come up with a more pragmatic reason. And a pragmatic reason why it's a bad idea is that if machines can decide to kill people, then they can decide to do it on an unlimited scale, because they don't need human beings to manage and intervene in each decision to kill another human being. And so you create weapons of mass destruction, and the swarms of small lethal anti-personnel weapons function as weapons of mass destruction in the same way that hydrogen bombs function as weapons of mass destruction, except that they're much cheaper and they don't leave behind a huge radioactive crater, and they don't destroy all the property in the process. So if you want to create cheap, effective, selective weapons of mass destruction that pretty much anyone on Earth can buy and deploy against you, then be my guest. The AI community is pretty united that autonomous weapons should be banned. And so there, I could go on and on. There, the misuse
Well, yeah,
sector of
right.
the
So no,
economy
I think that's a
is enormous.
that's a
But let me
fascinating example, and certainly something that people have been talking about. But let me perhaps, and I know you wanted to add something else to your thought, but let me put another one in there and see what your reaction is. For example, there is a lot of false content on social media, which is potentially making people extreme. I want to hear your thoughts on some recent events, such as, do you think artificial intelligence actually played a role in the insurrection at the Capitol? And if yes, in what way, if you could help us understand, and where are the limits today of all this spread of social media making people extreme, and the artificial intelligence that's playing a role in it potentially?
So that's a great question. Yes, I do think it played a role. Quantitatively, I think it's hard to pick apart, partly because the social media companies don't make their data available. And so there are many people who are professional researchers into just this area, and they have a very hard time getting access to enough data to do their work and to find out what happened and why. But I've written articles and op-eds about this general capability of AI systems to manipulate human opinions and preferences, and it works in a very simple way, right? So we put out machine learning algorithms whose goal is to maximize click-through, right, or engagement, or some other metric, but some metric that involves, how much people engage with content and how much value that delivers to the corporation. And in order to optimize those metrics, you might think, oh, the AI system is going to learn to send people what they're interested in. That's good, right? Better than sending people stuff they're not interested in. But actually, that's not what the algorithms have learned to do. The algorithms have learned to change people into more predictable consumers of content. Because the more predictable you are, the more they can send you stuff that you're going to click on. So they manipulate the human mind in ways that turn people into more predictable consumers. And that's an inevitable consequence of how we set up the objectives of the system. If you're trying to maximize something, and you're going to do it by taking actions that change the environment to produce the maximal quantity of what you're supposed to produce. And the environment here is the human brain that's attached, that's on the other side of the screen, so to speak. And so that's the environment that the system learns to manipulate. And I would argue that, in fact, we should prevent this in the same way that we don't allow pharmaceutical companies to produce and distribute drugs to billions of people that are psychoactive and have not been tested for safety and efficacy. Right at the moment, there's no filter between what the social media companies put out and the minds of people consuming it out there in the real world, and the facts seem to show. And again, I'm not the expert on the actual on the ground data, but as far as I can see from reading, the facts seem to show that the algorithms are having a significant effect. When you look at what kinds of content is being recommended on YouTube, for example, it tends to be the more extreme, the more violent, because that produces higher clicks. And it produces higher clicks because YouTube has trained people to like that kind of stuff. They didn't start out liking that kind of stuff. They were trained to do so. So this
So,
is an example of what goes wrong when you put out AI systems that are optimizing incorrectly specified objectives. So you asked earlier, what keeps me up at night? It's AI systems that are more and more capable, but they're pursuing objectives that are incorrectly specified. And that is a story that we've known for thousands of years, right? We know that when you ask the gods to give you something, you specify the objective, you always get it wrong. King Midas, wanted stuff to turn to gold, and his food and his drink turns to gold, and he dies, right? Any genie, the third wish is always, please undo the first two wishes because I ruined the universe, right? We know we can't do this correctly. And so, this is the reason why Alan Turing, although he was sort of partly responsible for initiating the field of AI, a year after his 1950 paper, in 1951, he said that once the machine thinking method had started, we should have to expect to lose control, because he did not see any way that the human mind could retain control over machines that are more powerful than the human mind.
So you mentioned control, and obviously you're a scholar in that, and you have written a lot about it, even in your most recent book. Some people feel we are already beginning to lose control over artificial intelligence. What do you think? Are we there already, where we are losing control? Are we, you talked about misusing it. Are we also overusing it, and are we losing control over AI?
So I think in the area of social media content selection algorithms, it's interesting. So even though those algorithms are really stupid, I mean, they're so stupid that they don't even know that human beings exist, right? They're only aware of the fact that a sequence of clicks occurs. So you are just a sequence of clicks. Everybody in the world is just a sequence of clicks on particular content. But because they're protected by giant multinationals and because they're generating vast quantities of income, we can't switch them off. And as they get better, right, the negative effects could become far worse, right? As they get better at manipulating people and learning how we work and learning how to press our buttons, the negative consequences could be far worse. So in that sense, things are out of control. And I think people are pushing back. So Tim Cook, who's the CEO of Apple, recently gave an interview where he was very forthright about the negative consequences and the fact that we have to rein in these algorithms. And I think governments are starting to see that something has to be done. The question is what? And how do you do it in a way that's consistent with Western ideals of freedom of speech and so on? So it's quite a difficult set of problems. And I think the answer is probably that we need robust third-party institutions that are not the government and that are not the content providers and social media platforms, but there's a sort of third-party notion of truth, truthing, let's say. And we have those already, right? We have notaries that allow the real estate economy to function. Without notaries and without land title registries and so on, which are arbiters of truth, the real estate industry would fail, right? It would be so riven with fraud that nobody would end up owning or buying anything. It would fall apart. We have similar things in the insurance industry, third-party verifiers of compliance with insurance regulation and so on and so forth. So it's not a new idea, but it needs a lot of institution design and thought to make it work. In the long run, I think overuse is another set of problems that we have to face. And so by overuse, I mean, in a sense, turning over too much of the management of our civilization to machines. And if you think about it, how has our civilization lasted for the time that it has, which is arguably, bits and pieces of our civilization have been around for literally millions of years. So, for example, the ability to form stone tools is something that hominids, so pre-humans, learned more than 1 million years ago and passed it down through tens of thousands of generations. That skill was kept. It was not lost and rediscovered. As far as we know, it was kept continuously over enormous periods of time. And then our ability to grow crops, to build wheels and wagons, and all our civilization is passed down from generation to generation by this process of teaching and learning. And if you add it all up, it's about 1 trillion person years of teaching and learning to keep our civilization going. We had no alternative because there's nowhere else to put the knowledge. You can put it on paper, but the paper doesn't keep your civilization going. It only helps when the next generation reads it. But now you could put it into machines, and the machines do the work, unlike the paper. And so if you lose that incentive, you lose the requirement, the physical requirement to keep up our civilization by reinstantiating it in human minds, what happens, right? What happens when the incentive to learn everything that we've known before disappears? That scares me because it's sort of irreversible. And there's a story called "The Machine Stops," which is written by E.M. Forster, who wrote a lot of cultural observation novels about late Victorian and Edwardian society. But he wrote this science fiction story in 1909, which is amazingly prescient. It has the internet, it has video conferencing, it has iPads, it has MOOCs, and it has overuse of AI, where human civilization basically turns over responsibility to the machine to keep everything running, and loses its own ability to function. And that, I think, is very hard to undo. So we have to figure out how to prevent it by some type of cultural imperative that's separate from the economic imperative that's been driving it up to now.
So that's fascinating and intriguing what you're just saying. But let me say, while in the long scheme of things, we might be able to prevent it, might be able to have some regulations, might have some thought process in it. In the immediate future, though, what are the 3 or 4 industries, for example, or areas you believe will be most impacted by AI, where perhaps the human jobs might disappear? And what kind of skills will still be in demand in that case for those industries? So if you could maybe comment on that a little bit, that would be great.
Yeah, I think this is something that economists, many leading economists now consider to be the most important problem facing the world economy. And it seems obvious that repetitive work of a physical nature has already been largely automated, at least in the developed countries. And repetitive work of a mental nature is in the process of being automated. And some economists say, oh, well, as with all previous technological revolutions, yes, there'll be a period of adjustment, and then new jobs will come into being. And we all used to be agricultural peasants. Thank goodness we're not agricultural peasants now, but we all have these nice jobs. Isn't it great? But they haven't explained, well, if it's not physical and it's not mental, what is it? And so when you ask them that question, they start to mumble and stumble, and they don't really know what to say. And I think the answer is that it's going to be interpersonal, and it's going to be based on the competitive advantage that human beings have over machines, which, as far as I know, is not likely to go away, which is the advantage that we as human beings know what it's like. So we know what it's like when you hit your thumb with a hammer, right? And if you don't, well, you can find out by hitting your thumb with a hammer. Now you know what it's like, right? There's nothing a machine can do to find out what it's like when you hit your thumb with a hammer, because it's not equipped with the same type of nervous system. So we use our own nervous system as a simulation of the nervous system of other human beings, and in particular of the subjective experience of other human beings. So we know what it's like to be jilted by the person you love. We know what it's like to lose a parent. We know what it's like to not come top in class, or to come bottom in class, or whatever it might be. And so we can help each other with this expertise. So when you look at the interpersonal professions that rely on this kind of ability, so they would include psychologists and psychiatrists, they would include executive coaches, but they would also include, elder care and childcare. And I would say by far the vast majority of those professions are actually low paid and not very skilled. And one of the reasons for that is not that we don't care about our children. So it's not like our children are, not significant, and so we're not going to spend a lot of money on childcare. It's that we don't have a science of how to do it well. And if we did, if we could really train unbelievably, exquisitely skilled professionals who could, using a huge knowledge base of scientific research and training, adjust their interactions with your child to really pull out the best from your child, given their personal makeup and characteristics and so on. We could maybe do a lot better. And we could add huge amount of value, and then those professionals, just like our orthopedic surgeons, are highly valued, right? They get $5,000-$10,000 an hour for their work because they have a science base to build on, because what they do actually fixes the broken bits, right? But for childcare, that's not yet true. In fact, probably childcare is about random in its effects on your child. Maybe sometimes people are good, sometimes people are bad. So if we're going to have these kinds of professions that will be areas where we want human beings to do it, and we want those human beings to be valued and to produce value, then we have to actually change our science. We have to change our education systems. And every government right now is worrying, oh my goodness, do we have enough computer programmers? But we don't need 2.5 billion computer programmers in the world. But we do need 2.5 billion people who can help other people have better lives. And that's going to be, I think, the future of the economy, is how you help each person have a better life. And then we need to develop all of the infrastructure to make that possible. And that's going to take
Stuart,
decades.
right. So I think you have done an amazing job setting us up with this. There's lots of food for thought here, lots of reflection to do based on what you've just said. And it's been such a great time talking to you to really set this series entirely for us for the February month, because there are a lot of topics in here which you mentioned, which we could go on and on forever to talk about. But we will be having those conversations with some of the upcoming guests, including conversations on governance and regulation and in responsible AI, and to keep it all going in the right direction, avoiding misuse and things of that kind. I think you've covered a lot of different topics to get us started there. But as a final question today, having gone over time, I still would like to ask you this to take advantage of your presence here today. As a researcher and as a professor and as somebody who has been pioneering this and having that kind of vision, we are getting all these guests who are coming in and talking from various lenses. I would love to hear your thoughts on some questions that you might want folks who are working in various areas. For example, our next session is with Dr. Nicole Turner-Lee, who's a senior fellow in governance studies and the director of the Center for Technology Innovation at the Brookings Institution. So what question would you like to ask her? Or we'll be interviewing Erin Egan, who is the Chief Privacy Officer of Policy at Facebook. And I would love to hear a couple of thoughts from you to wrap up this session today.
Well, yes, I would love to be there asking some questions as well, because these are such important questions for how the next few decades turn out. And if we get it wrong, then we could find ourselves in deep water. On the governance side, I would say that at the moment, it's not the right time to write regulations to prevent AI systems from taking over the world, because we don't yet know exactly how to design systems that won't take over the world. When we figure that out, and that's what my center is working on, then it'll be time to start writing regulations and say, look, you have to design your systems according to these safe design templates. And If they don't, then they don't get to be sold. They don't get to be deployed on the internet, and so on. So it's sort of like the rules that the App Store runs to make sure that your app doesn't mess with the iPhone and mess with the other apps running on the iPhone and so on. So they run a bunch of checks and they kick out your app if it doesn't pass the tests. And so we would have regulation of that nature for all AI systems at some point. But governance of the near term, I think we have to switch the mindset from where it is now, which is that the tech companies say, oh, don't regulate us, we'll regulate ourselves, and if you regulate us, that will kill the goose that's laying all these golden eggs. And look at, all those shareholders will be very unhappy. That mindset has got to change because we've seen these negative consequences and people are starting to call it out. Where can you plant a flag? That's simple. I think this should be a fundamental human right, and it should be something that's incorporated into the national laws of every country on earth. And I've yet to speak to someone who doesn't agree. So that's a place to start, right? And California has such a law, at least in restricted circumstances. And the EU is thinking about this and so on. So I think that's a flag that we can plant to define what rights humans have in the digital realm. But more generally, and I think this is something that Tim Berners-Lee is looking at with his new effort, is to turn around the whole structure of the information economy. If you take out your phone and look at all these apps, right, they're all corporate representatives. They all work for corporations, and they're busy in your pocket trying to extract as much data and as much money as they can from you. It shouldn't be that way, right? What should be running on my phone is software that works for me. And maybe it goes out and negotiates with some of these information providers on my behalf, and it warns me about potential violations of privacy and so on, but it's working for me. And those should be the apps that are on my phone. And so that's a change in the market structure and the whole economy, but that's the only way I think that we're going to fix these problems. So that's, again, a regulatory question, or the government sort of guiding the structure of the industry in this direction. And I think some of the industry players seem to be in favor of this. I would say maybe Microsoft and Apple, because they're not so much in the business of selling your data, would be supportive of that kind of direction.
Right. Well, thank you, Stuart. I think these questions are more than just AI. I think there are some wonderful questions that you have raised. It has been fascinating talking to you. I would also like to thank all of you who joined us today and invite you to the next episode of George Talks Business in the George Talks Business series on artificial intelligence. As I mentioned, our next guest is Dr. Nicole Turner-Lee, Senior Fellow in Governance Studies, Director of the Center for Technology Innovation at the Brookings Institution, and co-editor-in-chief of Tech Tank. And we will be joined by Dean of the School of Engineering and Applied Sciences, John Lack, who will co-host the session with me. Again, thank you for joining us today, and we look forward to seeing you next week.